All right, group, here we go again. This time we're working a projectile motion problem that involves something being kicked at an angle rather than being kicked horizontally. So we got a football kicked at ground level with a speed of 18 meters per second at an angle of 31 degrees to the horizontal. How much later does it hit the ground? So first thing I'm going to do, as always, when in doubt, draw it out. And honestly, even if not in doubt, I'm going to go ahead and draw it out anyway. So there's my poorly formed football. And my poorly formed football is going to be flying through the air. And one of the things that I know is that it will move an equal amount of distance in each time period while accelerating vertically to form that parabolic shape. And we are being told the initial velocity, which is 18 meters per second, at an angle of, a launch angle of 31 degrees. And we are being asked to find how much time is it in the air. So, how do I approach this? Same thing we've done before, same thing we talked about in class. I'm going to make my T-chart so I can keep the two axes separate, because I know that any motion in this direction is going to be at a constant velocity, any motion in this direction is going to be accelerated at a rate of 9.8 meters per second squared in the downward direction. What else do I know about this? Well, I'm gonna redraw this vector over here because I want to do some stuff with it. Because I can't do anything with this velocity when it's in both axes. All right. However, knowing that it's at an angle of 31 degrees, what I can do is I can find the two components that make up that velocity. I can find, don't want to do that. I can find the horizontal velocity component, and I can find the vertical velocity component at the moment it's kicked, which would make it the initial velocity in both directions. How do I do that? Well, this horizontal component is next to the angle. It's adjacent to the angle, so that's where I go back to so, ka, toa. Ka includes adjacent. Cosine equals adjacent over hypotenuse, and then if I rearrange that, that tells me that to find the initial velocity in the x direction, I would take the initial velocity times cosine theta, because this is the side adjacent to the angle. Since this is the side opposite to the angle, to find the initial vertical velocity, I would take the initial velocity times the sine of theta. I'm guessing this is going to be important information, so I'm going to include this down here. Especially since, let's think about this for a second. So I want to know how much time it spends in the air. Well, what's going to be the limiting factor that's going to determine how much time it spends in the air? It's going to be the fact that it's going to go up and come down. Gravity is going to accelerate. The moment it leaves the toe, the moment it leaves the ground, it's going to be accelerated downward by gravity, by the acceleration of gravity. Well, if that's the case, the only thing that's going to limit how much time that ball is in the air is going to be the vertical direction because of the acceleration of gravity. So I really only need to solve what's going on in the vertical axis. Well, what's happening in the vertical axis? I've just, I remind myself that the acceleration in the y direction is acceleration of gravity. Up here, I found out how to find the initial velocity in the vertical, just in the vertical direction. Okay, with the initial velocity times sine of theta. In this case, we know that the initial velocity was 18 meters per second, and we're looking for the sine of 31 degrees. And if I plug that in my calculator, making sure that my calculator is set for degrees, not radians or gradians, if I do that, I get an initial vertical velocity of 9.27 meters per second, 3 sigs, just like the two numbers that went into the calculation. And so that is, so its initial velocity straight up is going to be that. Now, since it's going up and coming back down to the same place, if I think about the velocity vector here, that ball is going to be hitting the ground with a velocity at an angle, which is going to include a vertical component and it's going to include a horizontal component. Well, one of the things I know about that vertical component is thanks to the two axes being separate, it's absolutely no different in the vertical component than if the ball had been kicked straight up and come straight back down. Well, if it leaves the ground with a vertical component of 9.27 meters per second, what's it going to hit the ground with? When it comes back down, it's going to go up, it's going to accelerate up on the way up for a certain amount of time, it's going to accelerate for the same amount of time on the way back down, meaning it's going to come back down to the ground with the exact same speed, but in the opposite direction. So I also know the final velocity in the y direction is going to be the same magnitude as the initial velocity, just in the opposite direction. I'm going to show that opposite direction with a negative sign. And I'm trying to find how much time it spent in the air. Well, if I know these things, I look at my list of equations, my kinematic list, and if I do that, I see that there's an equation that says final velocity, in this case in the y direction, is equal to the initial velocity in the y direction, plus acceleration times time. And I'm looking for this. So I do my rearranging, I do some algebra, I'm going to skip some steps here, but if you need to see the steps, let me know. And I end up with final minus initial velocity divided by acceleration. And now I plug those numbers in. My final velocity was negative 9.27 meters per second. My initial velocity was 9.27 meters per second divided by an acceleration of 9.8 meters per second squared. And I need to make sure to include that negative sign because direction is important. The acceleration is in the opposite direction of the initial velocity. And when I do all that and plug that into my calculator, I come up with an answer of 1.89 seconds. So the ball was in the air for a total of 1.89 seconds, which answers the initial question. But I'm going to throw in a bonus question for you. All right, bonus question. How far did it go? All right, well, how far did it go from here to here? Well, as soon as I talk about this, now I'm looking for a horizontal displacement. I need a horizontal displacement. What else do I know that's going on horizontally? Well, I know the initial velocity, but wait a minute, I can find the horizontal, just the horizontal component of that initial velocity. So let's do that. The horizontal component is going to be, as I wrote up here, the initial velocity times the cosine of the angle, which in this case would be that 18 meters per second times the cosine of 31 degrees. And when I do that, I find that horizontally it was moving with a velocity of 15.4 meters per second. And that's in the x direction. And now I initially listed as an initial velocity, but remember, what do we know about the horizontal direction? There's no acceleration there. So that's the constant velocity in the horizontal direction. We now know, thanks to this, how much time it spent in the air, 1.89 seconds. Well, if I know that and I know that, I can find that because I know that since everything is moving at a constant velocity in the horizontal direction, that it just obeys our definition of average velocity. And let's see, I'm looking for that. So a little algebra here gives me velocity times time, plug and chug. My velocity in the horizontal direction is 15.4 meters per second. The time spent in the air was 1.89 seconds. And when I do that, that ball was kicked, it stayed in the air for 29.1, or for a distance of 29.1 meters. So if I'm trying to catch my kick, I'd better be standing 29.1 meters away from wherever it was kicked. All right? Hope that helps. If you have any other questions, let me know. By the way, just because I'm showing you this in video, don't think I don't expect to see this worked out on your assignment still. All right?